Hey everybody, welcome back. In this video, you're going to learn about vectors and scalars. By the end of the video, you will be able to differentiate between vectors and scalars. And you should be able to do this both qualitatively in words and quantitatively, so by solving problems. So with that, let's go ahead and get started. So let's go ahead and start by comparing and contrasting vectors and scalars. Both vectors and scalars have magnitude, or size. We can also call that length if we want to. So both vectors and scalars are represented by a number, but vectors have direction and scalars do not. So some key examples of vectors that you've already learned about are displacement and velocity. One way that I remember that velocity is a vector, remember V for vector and V for velocity. Acceleration, which we're going to learn about a little bit later this unit, is also a vector. All of these quantities for all of these quantities, the direction matters, both when I add and subtract these numbers and also when I represent them on paper. So you should never be giving me a displacement without also giving me a direction. Scalars are directionless, and some good examples of scalars that you've already learned about are distance and speed. For both of those, I can represent them as just a number with a unit, so 10 meters or 17 meters per second. Time is another good example of a scalar. With that, I want to talk about how we represent vectors. So the easiest way to represent a vector is as a picture. So for example, I could draw a long arrow and I could say that it is 10 meters long. And that is how, as an image, I could represent something that is 10 meters to the right. If I was doing this on graph paper or on a number line and I had tick marks, I could also express my vector that way. Secondly, I can give a vector as a magnitude and a direction. So I could say that my vector, that same vector that I just drew for my image, I could also express it as 10 meters to the right. And that is giving me my magnitude, 10 meters, and my direction, right. I could also express a vector as a magnitude and an angle. And to do that, I want to remind you all of the unit circle, which you should have learned about in some of your others and in some of your math classes in the past. So remember on the unit circle, we represent the four cardinal directions, north, south, east, west, as angles instead. So instead of east, we have 0 degrees, north becomes 90 degrees, west becomes 180 degrees, and south is 270 degrees. So for example, I could represent my 10 meter to the right vector as 10 meters at 0 degrees, because my 10 meters on that unit circle is pointing in the 0 degree direction. If it was at 45 degrees, I would instead draw it like so. Finally, I can represent my vectors as coordinates in an xy plane. So again, drawing out your xy plane from math class, we have this is positive x, positive y, negative x, and negative y. If I was going to draw 10 meters to the right on here, starting at 0, 0, the point where my vector ended would be 10, 0. And that is how I would represent it in an xy plane. Finally, you should know that when you are looking at an equation, we're going to represent vectors by either using bold-faced font or drawing an arrow over the letter representing a vector quantity. And that is why both displacement and velocity are drawn with arrows over top the letters. The reason that we use arrows when we're doing something handwritten is because it's really hard to differentiate between bold-faced font and regular font with handwriting. So in a textbook, you'll see things bolded. When you write it, you should put the arrows on top. So to teach you how to add vectors in one dimension, I want to go ahead and start by doing an example problem. So Al walks 10 meters to the left and then 4 meters to the right in 2 seconds, and I want to calculate his displacement and his velocity. Since both of these are vectors, I have to do vector addition to calculate these two quantities. Adding vectors can be done with two methods. The first is what I call the graphical method, and that is drawing pictures. Second is through the algebraic method, and that is representing my direction as numbers. So to solve this problem, I do want to go through both of these two methods for solving vector problems. In the graphical method, what I want to do is I want to add vectors head to tail. And this is typically done on graph paper or a number line like what I have pictured below. And what I'm going to do is I'm going to go ahead and say 10 meters to the left is my red vector, and 4 meters to the right is going to be blue, and I'm going to represent displacement in green. And I'm going to do that for both of my example methods. So I'm going to start by having Al walk 10 meters to the left. So he starts here, and I'm going to draw a vector that points 10 meters to the left, like so. Then I'm going to draw my vector pointing 4 meters to the right, and I want to do that by connecting my vectors head to tail. So I'm going to draw the beginning of my new vector starting where my 10-meter vector ended, right at the arrowhead. And I'm going to draw a vector that is 4 units long, 1, 2, 3, 4, and pointing to the right. The sum of those two vectors is his displacement, and I'm going to draw that by writing a dot where Al started and drawing an arrow that points to where my final vector ended. That gives me a vector that is pointing 1, 2, 3, 4, 5, 6 meters to the left. And that is going to be my displacement. So through the graphical method, I found that my displacement was 6 meters left. Next, I'm going to show you the algebraic method. And to do the algebraic method, I want to decide first on what my frame of reference is. My frame of reference is going to tell me what direction is positive, and this is going to allow me to represent my vectors as just positive or negative numbers. So in this situation, I'm going to say that the positive direction is to the right. So my 10 meters to the left, I'm going to go ahead and represent, S is going to be equal to the sum of my 10 meters to the left and 4 meters to the right expressed as positive and negative numbers. So 10 meters to the left is just going to become negative 10 meters since it's 10 meters in the negative direction. Then I'm going to add whatever my next vector is. And my next vector is positive 4 meters since I'm going 4 meters to the right. A little more simply, this becomes negative 10 plus 4, or negative 6 meters. And since I've defined to the right as positive and to the left as negative, that negative sign already gives me my direction. To find my velocity, v, I'm going to go ahead and do velocity is displacement over time. It doesn't matter which of these two numbers I use. I get velocity is equal to negative 6 divided by 2, or 3 meters per second. So just like I can add vectors in one dimension, I can also subtract them. So for example, if I have 10 meters to the right minus 6 meters to the left, I have two different ways that I can solve this problem. This subtraction sign means in vector addition to flip the direction. So if I want to add these graphically by drawing a picture, what I'm going to do is I'm going to start with my 10 meters to the right, and I'm just going to go ahead and draw that vector. I'm going to attempt to draw in a straight line. That is something I struggle with. So it's not going to be quite perfect, but here we go. So I can go 10 meters to the right, and then I have my 6 meters left. But since I'm subtracting, I'm going to flip the direction, and my 6 meters to the left is going to become plus 6 meters to the right. So I'm going to go ahead and add these head to tail like so. And drawing a line from where I started, pointing to where I ended, I find that the sum of my two vectors is 16 meters right. And this is one way that you can subtract vectors in one dimension. A way that I have found is slightly easier for me to wrap my head around is following that same algebraic method that I followed in the previous video. So I can again define to the right as positive. So my 10 meters to the right becomes positive 10 meters. I keep my minus sign because I'm still subtracting my 6 meters. But my 6 meters to the left, I can just write as negative 6 meters. 10 meters minus negative 6 meters is the same thing as 10 meters plus 6 meters, or 16 meters in the positive direction. And I might put a plus sign in there just to indicate that I remembered my direction there. And so those are the two methods that I can use to subtract vectors in one dimension. And now that we've finished our definitions and examples, that brings us to some takeaways. So the first key takeaway is that vectors have direction and scalars do not. Second, displacement and velocity are vectors, while distance and speed are scalars. Finally, we can add and subtract vectors by deciding which direction is positive in our frame of reference. And you guys learned the definition for frame of reference. You also learned how to add vectors and scalars by drawing them on a number line. So again, we can add and subtract vectors as well by drawing them head to tail. And there you have it. These are your key takeaways for this video. Go ahead and try solving some problems on your own. Best of luck and happy solving.